we're going to have a look at similar shapes now, and we're going to look at 3 different ways that they can ask you questions about similar shapes. They can either ask you about length, or they can ask you about area, or they can ask you about volume. The 4th one we'll look at a mixture between area and volume, and that's when things get quite difficult. But for the most of it, similar shapes is fairly straightforward. Similar shapes is when one shape is bigger than the other, and that's the lengths. All of the angles will still be the same. So if that was 30 degrees, that would be 30 degrees. If that was 50, that would be 50. Okay, the only thing that changes is the length. And just to be a little more specific, when the length changes, every length has to change by exactly the same scale factor. So similar shapes are all about scale factors. And we will call scale factors SF throughout this video. And to find the scale factor, you usually take one length, and I usually take the big side and then divide it by the small length. So a scale factor is big divided by small. Once you've found the scale factor, it does become quite easy to pick marks up. So have a little go at this first of all. Now when it's got something to do with scale factors, press pause, look at each of the questions. For the first one, find X. For the second one, find the missing area. And for this one, find the volume. Okay. So in this case, I can see, I've been told this is a similar shape, so these triangles are similar. I need to identify the lengths where I've been given both pieces of information. I can't use these lengths because whilst I know that's 2, I have no idea what X is. But I know this is 3 and I know that's 12. So that's what I use to find my scale factor. And it's going to be the 12 divided by the 3. So in this case, my scale factor is 4. Once I've stated that my scale factor is 4, I can then show that X is going to be equal to the 2 centimetres multiplied by whatever I said my scale factor was. So in this case, 4. And 2 centimetres times by 4 is going to give us an 8 centimetre answer. Okay, so the missing length here, X equals 8 centimetres. Likewise, if this question had, instead of the 2 and the X there, if they wanted, now if they had told you that, I don't know, this was maybe 20 centimetres on that length, and they wanted to know what that length was, in order, because you're going from the big to the small this time, you do exactly the same to find the scale factor, but then you divide. So you would have done 20 centimetres divided by the scale factor of 4, and that would have given you a 5 centimetre length. Okay. Moving on to area, we still have to find a scale factor because similar shapes are all about scale factor. But in this case, because area is always measured in squared units, or centimetre squared, metre squared, the scale factor also has to be squared. So I can find the scale factor, as I did above, by taking the lengths that go along with each other, so 5 centimetres and 15 centimetres. So my scale factor here is 15 divided by 5, which is 3. Now, in order to find what the missing area is, I can then say that it's going to be the 10 centimetres squared. That was the area of my original shape, the smaller one. And I'm going to need to times that by my scale factor, which was 3. But because it's area, which is in squared units, I need to times it by the scale factor squared. So in actual fact, what I end up with here is 10 centimetres squared times by 9, which is going to give 90 centimetres squared. So the area of this triangle is actually 90 centimetres squared. The most common wrong answer being 30 centimetres squared. So with area, we had to square the scale factor. It only stands to reason that with volume, because we're working in cubic units, whenever we're dealing with volume, centimetres cubed, metres cubed, if we've got a volume of 50 centimetres cubed and we need to find what the volume of the bigger one is, first thing we do is find the scale factor. And again, we can do that using the lengths we've been given. So the scale factor of this is going to be 12 divided by 6. So this has got a scale factor of 2, which means every length gets multiplied by 2 to get to this shape, or divided by 2 to get back to the small shape. However, because it's volume, we're not going to just multiply by the scale factor, we're going to multiply by the scale factor cubed. So the volume of the original was 50 centimetres cubed. I need to times that by my scale factor, which was 2. And because it's volume, I times it by 2 cubed. Now, 2 cubed is not 6, it's 2 times 2 times 2. So 2 times 2 is 4, times by another 2 is 8. So this is actually 50 centimetres squared times by 8, which is going to give us 400 centimetres squared. Okay, so the volume of this is 400 centimetres squared. The most common wrong answer, of course, would be 50 times by the scale factor of 2, which is 100. So that's not the case. It's 400 centimetres cubed. Oh, and over here I said squared. I shouldn't have. It's cubed. And there, cubed. Okay. Now, for the more difficult one, looking at it, hopefully you can see why it's more difficult. And that's because I haven't given you any dimensions of the lengths. In fact, the only comparable measure I've given you is in terms of the area. So I've told you that the area of the small cuboid is 25 centimetres squared and the area of the large one is 100 centimetres squared. Now, I still need to find a scale factor. So in order to find the scale factor, I'll follow the same process. The big divided by the small, so 100 divided by 25, which is 4. Now, you need to be aware that whilst that worked to find the scale factor of lengths, because it's in one dimension, we're actually working with area here, which is squared, so in the second dimension. So actually what we've found here is the scale factor squared, which is 4. Therefore, the actual scale factor is going to be the root of 4, which is 2. So our scale factor is 2. Now, we've been given that the volume is 50 centimetres cubed and we need to find the new volume. And because we're dealing in volume, I need to be aware that I'm in cubed terms again here. Now, this is in squared terms in 2D. That's in normal centimetres or metres, that's 1D. We're going to be working with volume, which is 3D, so cubed. So I've got 50 centimetres cubed, which was the original volume, times by my scale factor, which is 2. And because it's volume, we need to cube it. All right? So I end up with 50 centimetres cubed times by 8, which is going to equal 400 centimetres cubed. Okay, so this is more difficult because they're giving you the scale factor with regards to the areas, not the length. So they want to see, do you know how to get from an area scale factor down to a length scale factor and then back up to a volume scale factor?